Thanks everybody for attending. This is DevHead's office hours for the week of January 26th, or the Friday of January 26th. Let's go through and do some quick introductions. Just say hi to everybody. You can just say your name and then like what you work on. You don't have to say your name if you don't want to, but yeah, don't go too in depth just so we don't get bogged down in that. So I'll go first. My name's Brandon. I've been a deep tech journalist for about 15 years, and I'm really excited to be building and seeing the server grow. So Petr, do you want to go next?
Yes, I'm Petr Dvorak, living in Czech Republic. I'm freelancing hardware design engineer for 6+ years, and yeah, this is me.
Mesh, you want to go?
Yeah, so I'm Umesh Lokhande from Pune, India, and I'm designing embedded systems since past 10 years. I've been involved in a lot of IoT projects. So IoT is basically what I sell and build. That's all I have. Yeah.
Great. Mike, you want to introduce yourself real quick?
Yeah, Mike Farian. I've been in this IoT game for a few decades now, starting with machine-to-machine communications and IoT, and I'm kind of more on the business technology strategist side of things.
Cool. Abhishek, want to say hi?
Yeah, I'm Abhishek, living in Bangalore, India. I do IoT as well as embedded Linux.
Cool. Christoph, say what's up.
Yep, I'm Christoph. I'm co-founder of mBeetle IDE. So feel free to check it out on mbeetle.com. It's an IDE for microcontrollers.
Shrisha.
Hello guys, I am Shrisha Nakshatri. I'm from Bangalore, India. So I am an embedded hardware engineer. So I mainly focus on microcontrollers and mainly PCB designs stuff.
Cool. Well, thanks everybody for joining. Everybody else, if you don't have your camera and mic on, and you want to say hi, just put it in the chat, and I'll check over there and tell everybody who you are at some point. But let's just get right into it. What we're going to do today, we already went through this slide, is talk a little bit about PCB design best practices. I don't know if you guys saw, but yesterday we published the second of our DevHeads demos. These are these short 5-minute clips on different engineering challenges that we're publishing on YouTube and then promoting out through LinkedIn and other channels. And our guest was Petr, and we talked really quickly about some of the things that could be really quick pitfalls if you're going to PCB manufacture and you haven't checked yet. And he gave 4 tips. So we thought, hey, what a better topic than to have him come on and dive into that a little bit more, go a little bit more in depth. So we're just going to sort of riff here. Petr's a fantastic resource in terms of all things hardware design. So you can find him in the server at Petr Dvorak if you have any questions about anything related to that stuff. And I guess, I mean, he's already introduced himself a little bit, but I'll hand it over to you, Petr, if you want to say more about yourself and get us into it.
Yeah, sure. Thank you
Well,
for the mic. Yeah. Yeah, I have been freelancing for 6+ years. Before that, I had worked for a few companies. So I'm 43 this year. So I have like 20 years of experience on my belt, but nothing special. I focused on microcontrollers, digital and mixed signal electronics, partly analog. I offer my hardware design services to customers from around the world using LinkedIn as a main platform for my personal presentation, brand awareness. I don't know how to say. So yeah, this is what I do, and I prepared a few slides, and we recorded, as Brandon said, a second demo for our community server, and I I'm going to say a little bit more because we are not so time limited as during the recording of the demo. So yeah, I think the speech or the presentation will be especially beneficial for all beginners who somehow are confused with all the parameters that PCB manufacturers offer on their websites, and confused with all the numbers that their ECAD system asked for enter. So I would like to keep the minimum needed to successful PCB layout design and focus on things, on the most important things, and the rest will be left until you will be more advanced or professional or expert. So yeah, I'm going to share my screen, so please give me a second. Oh. More than a second. Share a screen. So you should see the blue slide. Do you?
I don't see it.
Don't see.
Remember last time we had to reload the page, Petr?
Uh-huh. So in that case, I need to.
It's a holiday weekend. You guys got any big things planned in India? Sricha, you're muted. He's the only one.
No, nothing really planned.
No.
Just yeah.
Hey, actually, Christoph, I was watching the recording from last week, and I saw that you'd injured yourself.
Sorry.
Oh, it's all
I'm
right.
sorry for the trouble. Now it should work.
Okay, I'll talk to you about it after, Christoph.
Okay.
Can you see anything? No.
Nope. If you want to drop the files to me in Discord, I can run it.
Should be better. Okay. So.
But yeah, Christoph, what happened to you?
Yeah.
What happened to your head?
It's very silly. So I was ill. I had a virus, or I eat something wrong. I don't know. But at night I woke up and I was feeling nauseous, and so I stood up and I walked to the toilet. And on my way, I lost consciousness for maybe 1-2 seconds, but that's enough to really fall badly and hurt myself quite a bit.
Oh man, wow.
Yeah, it sucks.
Yeah, what'd you hit your head on? Holy crap!
In the doorway, it's I have this special kind of sliding door, and the sliding door in the fitting it closes. That fitting is apparently quite sharp. That's what I experienced.
Yikes!
Yeah, it sucks, but well.
Man. Sorry to hear that. Well, here's Peter's coming back in right now.
I can try to do like this, so it's not as.
It doesn't look bad. It's just.
Yeah, it's going to be a scar.
Yeah,
Like
sorry.
in Harry Potter.
Okay.
Yeah.
Let's see if Petter's
Yeah.
back in. If he's joined. There he comes. Let's see. There you are.
Hi, Peter.
Oh, thanks, honey. Okay. There we
Yeah.
go.
Yay!
Boom.
We have.
And then there was
image.
light.
Yeah.
All right. I think you're muted though. Peter.
Peter, you are muted.
There we go. I unmuted him for him.
Oh, good.
So
Just
now
so you
you
know, I can unmute you.
should hear me.
Yep.
Can you
Yep.
hear me? Yeah,
Loud and
perfect.
clear.
I'm really sorry for the
Don't worry.
troubles. So the first thing I would like to say that the minimum through-hole diameter is the first critical parameter you should set in your CAD system. The minimum through-hole means that the minimum hole that PCB manufacturer can drill into the PCB. It's connected especially with vias because THT pads for components doesn't have such a problem because we are speaking about 0.2 millimeters diameter, not 1 millimeter for typical THD components. So please check that parameter carefully, and I recommend not to go to the lowest limit, to keep some room for tuning. So yeah, the issue is that your CAD system, either KiCad, Altium Designer, anything, doesn't have like firm limits. You can set smaller diameters than the PCB manufacturer can drill into the PCB, and then they can charge you for extra money because you exceed some classes, or even they can say that your PCB is not manufacturable at all. So be careful about the minimum through-hole. The second parameter connected directly with that is the minimum annular ring. It means the ring around the hole, the minimum ring, as well, especially connected with vias, because pads are usually bigger. So let's say we have a 0.5 millimeter drill, and the minimum annular ring is 0.25 millimeter. You can go below that 0.25 because then the PCB isn't manufacturable at all, because that ring is too small that the process doesn't keep it on the surface of the PCB, and yeah, the PCB is not manufacturable at all. So be careful, because the vias is not only drill, but the drill plus the annular ring. The third one is more natural, and it's minimum track width. So it means how your thinnest tracks can be in wide, can be, yeah. So I think it's self-explaining. If you go below that limit, your PCB cannot be produced, or you will be charged with extra money, because for example, once you lay out the two-sided PCB with normal limits, you can go for, let's say, 0.1 millimeter, but then you can drop into a more expensive class, and your PCB is then taken as a HDI or something. So be careful, because too fine tracks means your PCB will be really expensive or will not be manufacturable. And the fourth parameter connected with the track width is the distance between tracks. So as the same as for the tracks, when the tracks are too close together, the PCB, or too close to each other, the PCB can be produced, or for extra money. Those are 4 parameters I recommend to focus on. If you visit PCB website, the website of PCB manufacturers, for example, GLC PCB, you can find in the section usually capabilities or technology limits or something. So let's say GLC PCB, call it capabilities. And you scroll down, you can find section drill holes, minimum annual ring, minimum clearance, minimum track width and spacing. Yeah, I've taken the pictures from the GLC PCB. And you can see the numbers varies if you are talking about two-sided or multi-layer PCBs. Yeah, I wanted to say that I picked up 4 parameters. There are on the web page there are tens of them, but
Christoph, you have something to say?
I have a question, but if it's okay, Peter, to interrupt. So
Yeah.
on the
Go
website
ahead.
of GLC PCB, you show the minimum parameters there in this website, but are the numbers given there, are those, for which technology class are those? Because I've also seen this website before and I was confused because GLC PCB doesn't specify if these numbers given on this page are for the cheap manufacturing or if they are for, you know, a higher technology class that increases the price. It's a bit unclear to me. Is this something you know more about, or?
You are right. They are not specified the classes for the PCB, and I am somehow happy for that because I have never understood the classes. For example, Euro circuits specify and distinguish between classes, but to me it's not legible their representation of classes. So
yes, I agree with you on that. The way Euro circuits describes their classes is quite confusing. Yeah.
I recommend going not below that limits I'm presenting, and the PCB manufacturing process is not like to design something, to send it to the production, and to wait without any issues. So the first orders are for you to steep on the learning curve. So yeah, I think take those numbers, use it in your design, and if there are problems, communicate with the representative of the PCB manufacturer, because this is the only way how to you can learn. And the PCB layout is barely universal. The first thing you should need is to pick your PCB manufacturer and to design the PCB for them.
Yeah.
Of course, the normal PCBs, like the regular, like the DIY or the normal electronics PCBs, can be manufactured even at GLC PCB, Isler, Euro circuits, anywhere. But this is not how the industry really works. You need to know your manufacturer and you need to know their limits. So yeah, I know it's confusing, but try to find those numbers and don't go below them. Use for example GLC PCB for 1 and 2 side PCB. Mentioned that 0.127 millimeter. So I would be quite conservative. I would set 0.15 or 0.20 even, because that 0.127 is really thin, really fine track. But if you set if you set in your KiCad or CAD system 0.127 millimeter, you should be not safe, but you shouldn't be in the danger area. This is my point of view. I don't know if I answered the question, but yeah,
so you advise, instead of going for 0.127, to go for 0.20.
For example, 20 or 15
Yeah.
or 16 or something.
15. Yeah.
Definitely not 0.12.
No.
To keep some room, because even the CAD system doesn't keep the distance, and the track width is kept, but not when speaking of clearance. Somehow, in using the copper pores and polygons, you can go slightly below, and then you would drop.
And if you would go slightly, let's say if you're a risk taker, I'm just hypothetical. So you're a risk taker and you say, okay, I'm going for exactly 0.127 in KiCad. And then you do copper pores and everything, and you do DRC rule check. Won't the rule check figure out if there is a violation, or could it somehow miss something and that you somehow violate the 0.127 regardless? I mean, is there any
you showed me an error in KiCad or something like that, like bug. I've never seen before, because the clearance parameter is set for the polygon, and even the tracks are their net classes with track width and clearance. So this shouldn't happen, but as you reported, it happened. So keep some room.
Okay.
Don't use the minimal. Okay. Yeah, probably I should mention in the presentation that you shouldn't set the minimum numbers. You should look for minimum numbers. This was the correct presentation this should be the correct information I wanted to deliver, not to set the minimum numbers.
Okay.
Christoph, I have some experience with JLC PCB. So when you're seeing here the minimum numbers, right? This is not absolute. So it will depend. So when you send your file, and they will respond back to you if it is possible. So some of the things which I have mentioned here, like you will assume like these are the standard numbers, but no, sometimes they give like even higher minimal spaces. Actually, like in the mail which they respond, they give you the higher numbers to go with this. So I have some experiences, like I had to redesign many boards like this, because they're like this. Because I was designing some Wi-Fi modules, so there the wire sizes were very small. So those wire sizes, like I had gone like really close to their limit, and still like they are saying like in the mass production, like in thousands of numbers, we cannot do this parameter. You will have to pay extra, like $100 extra, like that kind of charges. They were adding on top of it, because these are the low cost Wi-Fi modules, so we don't want to increase the cost. So I had to redesign the board. And it's very hard, like your IC is very small, and then the wire size is big, so you have to match that. It was a struggle there. So don't take these numbers like standard numbers. Okay, so when you send your file, like assume like they will respond back to you like some of the parameters will not match, so they will ask you to like redesign it and send the Gerbers back. So I have experienced this. So keep like a headroom above like a minimum value what they have set. Keep some above headroom. So the thing is, like once they had done it, so like the number were like in 10 numbers, the board were like it was very close to the like minimum spaces. So the 10 numbers they had made it fine. So when we asked like thousands of them, they were like this will charge extra because this will take like little more effort, so we will charge extra, they will say it. So they will like clearly they have like some analytic tools that will analyze everything, like spaces, like wire sizes, everything. They will even like highlight you where the errors are and everything. So they will in their mail they will respond all the issues. So this is some of the things like I have faced. So like these numbers are not absolute. Don't take these numbers of like absolute. Mainly like the wire sizes. So the wire sizes, if you see here, like you will assume like 2 to 4 layers, they have given like 0.2 and plus 0.2 is the whole size, and plus 0.15 on top of it. So it would be 0.35 would be the angular ring, so like diameter of the wire. So if you take that as like the wire size, they will reject you, like they will like send it like can you increase the wire size, we cannot do this. So I had to go for like 0.2 and 0.45 like wire size. Like that is very small, but in when we are designing like a small Wi-Fi module, like that wire is like very big actually. Like, so this like my experience.
Yeah, that was an excellent note. I wanted just to add that the PCB is not just the PCB. For example, the technical requirements from the PCB manufacturer is that you need to cover each layer with at least 30% of copper. So, for example, once you use very thin track on the PCB where there is less than 30% of copper on the layer where the thin track is used, then the technology, the chemical process, the etching doesn't work as expected. So they even may refuse the work, the PCB in production, or set the email, or the representative will contact you. Hey, this is under limits. Please make this track thicker, or use copper pour to cover the layer with more copper. So the quotation tool at JLC PCB works really well. They charge you with money, you pay, but after that, the manufacturing check is done by the human engineer with the better tools, and then they get back to you and say, hey, even though the system said it's okay, we find the issue, so please correct it, because then otherwise we will charge you with money, or we will refuse the production. So this is how the process works, and after a run or two, you would go like without any problem for the PCB to be manufactured. So this is the way.
So the message from all of this is you should keep a margin, a safety margin for both the vias,
definitely,
the track width, everything.
Definitely
Okay.
Keep a margin. The 0.127 is like really thin, thin track, and a really narrow clearance. I usually don't go below 0.20.
Okay.
Only very fine, very with very fine pitch connectors or BGAs, I go, for example, to 0.16 or even 0.13. But be careful, and double-sided or even 4-layer boards keep a headroom, and 0.20, 0.18 should be fine for you, and you should be able to finish the layout with that.
Okay. Yep.
Yeah, and I don't know why those parameters on the website of PCB manufacturers are somehow confusing. I picked the JLC PCB because, to me, the JLC PCB explained everything clearly and legibly for almost everyone. Yeah, there are every time you can find a gap in understanding or in information, but I picked them as an example of a good presented information source. So thank you. This is all for me.
Awesome. So Christoph obviously had some questions. If everybody else has questions, feel free to ask. I think we're going to go into our little open discussion period here. Do you have a question, Umesh?
Yes, I'm audible, right?
Yep.
Yes.
Yeah, so I have a question. It's not really related to what we talked about, but it's in general, because you've been, experienced person, very much experienced, right? You have probably tried many tools. So, I do PCB design, but I just try and do, easiest way possible. Okay, take a shortcut. And always my focus is to what easiest way to done is, and one technique I remember those days I used to use Eagle for PCB design, and even it's long back. I created even the videos and stuff, and I was using it for my startup because that's the easiest you can get when you start company. You don't have money to pay. But the auto routing tool of Eagle still a little bit better even back in 2013 or 14. And right now I use very professional tools. I get free licenses, even I have a paid version as well, right? But even a lot of noise right now. AI will do this, all those, fun fancy stuff. My question to PCB design people, experienced people is, if they cannot simply solve this auto routing problem, okay, which is nasty, ugly. I tested last time in 2013, and then I tested in 2019 and 2020, and then I never looked where this icon is and what it does. So I want to know from you, like, what you expect auto router, because routing is something like, if you're not a seasoned, if you're not a PCB designer every day, you do PCB design like me. I do, I analyze, I sometimes do, and a lot of my work is a firmware. And if I have to do it, it's very rare occasions. And I kind of very, curious to know why this auto router is not there and when it will be there or ever will be there, because PCB, even the expectation from the PCB like 2013, 14 was very different. Right now are very complex. So number one question is, this auto routing, like, what is your opinion, and where it gonna go? Do we see, forget about AI, but do we see significant contribution improvement of auto routing?
Yeah, thank you for the
That's my
question.
question.
I started as well as you with the Eagle, like 20 years ago or somewhere, and I was happy with that. There is a auto router. We were my colleagues in class. We were all happy that Eagle has auto router, and let's do it. Let's use it because it's cool, and we will have our PCBs without any work. But it doesn't. It didn't really work, and as you said, it doesn't really work even today. And my predictions, I recently discussed with representative of Altium designer here in Czech Republic, because I was interested in the introduction of AI into the tools like Altium, Cadence, or CAD, Siemens. I don't know how to say that Siemens tools right now. They told me it will be soon, and it's not ready yet. So I believe we are at the beginning of the era where the auto routers will really work and really help us. Those auto routers in the old Eagle and currently used software are not good, simply said. So my opinion or my answer is wait, and I think in a year or two we will get the helpers or copilots auto routing for us with better performance than ever before. This is everything I know. And if I may, I have never used auto router in the recent 15 years because it doesn't work. And I really look forward for that tool that will really help and really work. So yeah.
So my expectation, Peter, is, I remember when I used it for first time. Of course, in those days also it didn't work as we wanted, but it helped me to optimize 30, 40%. So what else remains is like 60%. I can optimize it myself. I can delete some track and I redraw and route it again. I will still be happy. But last time when I tried with more advanced tool, more expensive tool, it was even worse than that. And then this AI wave kicked in 2023 beginning, and then I see, what the hell happening. People here, one side people are talking about, AI will do all your design, and here the feature which was in queue for, let's say, past 10 years, and it's not improving, and where the hell this AI is. So that was,
Yeah.
so even if
But
it does 40, 50% optimization, I think still developer will be very happy.
Yeah,
Because
exactly. Exactly. As the copywriters and marketing people and everyone as engineers use ChatGPT or other language models to help us, not to make the work for us, but to show the track to the goal. So I asked the Altium designer representative why the co-pilots are not ready yet, and when will be ready, because I'm using KiCad, but if the copilot of Altium Designer will save me hours a week, I would definitely go for Altium, because my time is limited, and I'm not here to make heavy lifting all the time during the PCB layout job. So yeah, they started with like the copilots with copying the blocks and optimizing components placement, but it's like, I think it's only like teasers for the future functions, or I don't know. The AI can do miracles, but the PCB layout area is not touched yet, almost. I don't know why.
Why I asked this question is, maybe you will find it very funny. Okay. As I said, I'm not very seasoned. I don't wake up and then sit with schematic sheets. Okay. So when I stand right next to schematic sheets, it's probably the craziest time because I have to do it. Okay. So if I do schematic and then I have to do board layout, for me, I have to take a lot of break because I have to take my brain from schematic and then I have to visualize and sit. You know, this time takes a lot of slips in between. So it's not about engineering, it's about to make your mind to, you know, program to do certain things, to tell your brain. I mean, I think this is the problem that it will solve, rather than of course then there will be engineering will involve. So engineer will put more thoughts, more engineering approach, like the distance and tracks and other things. But this time which I shared with you, you wake up from the bed, you look at the schematic, then you press that button, then you think this whole thing is in itself is a 8 to 10 hours to make your mind. If you're not daily PCB designer, if you're not daily hardware designer.
Yeah, I agree 100%. The schematic, I can see the schematic as a single level, single layer thing, but the PCB layout is like multi-layer. Like you need to switch your brain to like to parallel computing, because you need to calculate where to place the component, how the future tracks will be routed, and how to avoid conflicts, how to avoid crossings, how to use multiple layers if you can. Yeah, you are right. It needs a training. It's something you need to learn, but it needs time to get into it. So yeah, I would like to give you a good tip or advice, piece of advice, but it takes time. It's like training, like for a sport or something. You need to get into it. You need to spend hours doing it, and then you will getting better and better.
Thank you.
Yeah, hello, Christoph. You are muted.
Sorry, I also have a question. So I've never used microvias or blind vias in my designs, and I was wondering what's your opinion on them. Did you ever use them in your designs, and what's your experience with this?
Sure. It's like a very special technology for high density PCBs. It doesn't. It's not something you need to worry about. Only I would like to give you a short introduction about the technology. Once you drill the hole into the PCB, let's say 1.6 millimeter as a standard thickness of PCB, there is a like 1 to 10 ratio. The minimum hole can be 1/10 of the thickness of the PCB. Otherwise, the copper that must flood into the deposit into the hole doesn't get through the hole, because the the hole is too thin that the copper doesn't travel to the end of the hole. So micro wires are very thin, very small hole wires, and it means that, for example, 0.1 millimeter or even less. So if you go opposite way, you need to go only when you take 0.1 millimeter micro wire. So times 10, only 1 millimeter can be the length of the via. Yeah, so not be used through the entire PCB because it's not manufacturable. Only for internal layers or used as a blind via. So from top to inner, or from inner to bottom, or between the inner layers, then it's called the buried vias because it's buried into the PCB mass. So this is only difference from the normal THT vias. The drill is less, this is smaller, so the height of the via must be shorter because then it's not manufacturable because the copper doesn't go through the very thin hole.
And if you have a design with like blind vias or buried vias, like what you describe, then if you manufacture it at, for example, GLC PCB, will they charge extra for this?
Yes. This is technology which is I don't want to say very expensive. It's slightly more expensive because the technology is pretty normal these days. It's not something special. It's not rocket high technology. But it takes some money because it's something not normal for normal PCBs, but it can be. For example, the vias in pads. Normally there is a SMD pad. You need to route short track and then to place via to the internal layers to the opposite side of the board. Once you have a very fine pitch PCB, BGA, for example, package, there is no space for via in between the pads. So you need to place the via inside the pad. But the copper, the solder, the paste must be placed on the pad to solder the ball of the BGA. So once you have the via in pad, there is normally a hole. So the solder paste will go through the hole. So you don't allow this because then the soldering will be incorrect because you need to solder paste on the pad, between the pad and the BGA, not in the hole. So you need to use the tinted. It will suck into the hole. So you need tinted vias. The vias are filled with epoxy and covered with copper again. So this is the plated, so-called tinted vias. So it's tinted, as well tinted. It's a paid. It's for extra money, but nothing. Nothing super expensive. But you need to calculate with some extra charge from the manufacturer. Some technologies use it innately. For example, the Slim Flex I posted recently. There are normally buried vias and the blind vias. Normally, there is no extra charge for that because the thin of the PCB is 0.2 millimeter. So there are almost no limitations on the normal PCBs with 1.6 millimeters or similar. So it depends on the technology. So this is why I said go for the website of the manufacturer, pick your PCB manufacturer, and go for the numbers because it depends. It varies between technologies. It varies even between PCB manufacturers. Some manufacturers are oriented for very precise HDI designs. Some manufacturers are focused on hobbyist, DIY boards. So the technology differs because their machines are not so fine, so precise to manufacture everything for you.
Thank you.
So I started my career with a company called Orbotech. And Orbotech is the company who produced the most expensive machines for the PCB design. And the reason those things are expensive, because those machines are super, super expensive. And those machines will be more than this room size. I mean, 4 times, 5 times. And usually because of those technologies and machines and accuracy cost money. Just a short thing.
Exactly. The money, the accuracy, the stability, the time stability, the everything, because you need the same parameters in the morning and in the afternoon, or all the time. For example, drills. You know the drills for your drill once you drill the piece of wood or your wall in your house. But those drills able to drill 0.1 or less drills into the PCB, they are completely different. Rather wires, not the drills, and they use laser drilling for really extra small drills. It's a very precise and accurate technology for the HDI boards.
Very complex.
Yes.
Hey guys, I didn't want to interrupt the flow, but going back to a topic we had earlier, it's funny we were talking about AI and hardware design, because Navadeep actually just wrote a blog on this specific topic on his GitHub blog, so it's worth checking out. He's talking about a lot of the limitations that we were just saying. Yeah, that still
I will
exist.
definitely read that article. Please, can you share it?
I put it in the chat.
Perfect. Yeah, I can see it in the chat, but I think it's worth to have it on a Discord server.
Yeah, it's somewhere in the server. I can't. I was looking for it. I was looking for it. I'll repost it in the server, so you guys can give it a read.
No problem. I will open it in my browser and later read it later. Yeah, thank you for that.
Sure. Yeah. So this is Abhishek, go for it.
You are muted. Yeah. Okay.
So just as an insight, I was just scrolling Instagram and I saw this page which is named as Build with Flux. They are promoting their website named as Flux AI. They are apparently doing the co-pilot and other stuff of AI into the hardware world. Has anyone experienced that website or like products of that website? Does it really work?
Yeah, I tried that service, but I stopped because I stopped using it after a few minutes, because they wanted to send me all the project data to their server, but it was my customer's data, and I was not allowed to share it. This is the first thing I need to ask each such a company, because my customers want me to sign NDAs and everything, and I am not allowed to upload all the project data to some cloud system, because otherwise, all the NDAs lose meaning. So I looked at the Flux, I looked at the other, like circuit magic or circuit design recently, but I stopped at that point. For my designs, I can use it, but not for customer design. Unfortunately, I'm working mainly on customer designs. But let's give a try. It can work for you.
Maybe let's it's just like interesting. This thing came into my feed, and I was just like curious about it. Basically, again, what they are having is a LLM model for the training purpose of this tool. So they will be requiring the user data to train themselves and do it better.
Yeah. I was presented, or representative of the Circuit Mind, or I don't know what the company is called. The demo, they offered me a demo and full support for KiCad and everything, and they presented the features of the tool, but the tool was able to design the schematics of like the generic designs, like microcontroller to connect some I2C sensor, power supply, decoupling capacitors, and button. Yeah, but not every design look like this. Not every design is like generic. It's more complex. So I'm really looking forward for such a tools, but they are not ready yet, and probably we should use them to make them better. But yeah, it's up to us.
Right. Guys, I have to excuse myself. I have to go to pick up my son from school. But I just wanted to 1 minute just to say that about the tiny Scarab board. I still have to go over all the suggestions from Peter. So I'm going to do that because Peter made a whole list of suggestions for my board, and I want to take my time to go over them one by one. That's one thing I wanted to mention. Secondly, the TVS diodes. We had a discussion on the general chat about if they are necessary, yes or no. Well, I think the discussion can benefit from this new information that I found, TVS diodes that are almost an order of magnitude cheaper.
Mm-hmm.
And I believe they are sufficiently okay for our board.
Mm-hmm.
I posted them on the general chat, and yeah, feel free to have a look and to give your opinion on that.
Sounds good. Just one point. Be careful about the capacity of these TVS diodes when using for communication buses.
Absolutely. So the TVS diodes I figured out, I found was 5 picofarads.
It's quite good.
I think it's okay for the I/O pins. I can stick to the 1 picofarad more expensive TVS diodes just for the USB.
Yes.
And then take the 5 picofarad ones for all the rest. That's an option.
Good plan. Good plan.
Yeah. Okay. Perfect. So now I have to go. My apologies.
Thank you, Christoph, for your questions, and have a nice evening.
Thank you so much. Thank you, Peter, for the interesting presentation, and all of you guys for the meeting. Thank you very much. See you.
Bye.
Bye.
Okay, guys. So I actually have a hard stop at the bottom of the hour too. Typically, this is where we go through questions from the community. I don't know if we're going to have time today. I pulled out a bunch over the last week. This is sort of my best practice right now, is I'm just going to take out questions that have not been answered or, may need additional follow-up from over the past week. Actually, Petr went through and answered a bunch of these. A couple in particular, if you have a chance, this one from Jeremy, nobody's touched on yet. He's got some questions around anybody who's ever worked with MIDI on a Wemos S2 board. Also, Budmalia needs, or Electroboffin, however he's going, whatever name he's going by these days, needs some help with the SB32 module schematics. So that's one there. And then I know Abhishek, you jumped in and tried to answer a little bit about this TensorFlow Lite on a Raspberry Pi Zero. But if you guys have a chance, check these out. They'll be in this slide deck, which I'm going to keep. I'm going to upload to the server anyway. So just keep an eye on those. If you have any thoughts, just drop them in those channels. And progress. So DevHeads demos. Obviously, this conversation was based on a demo that we had done with Petr. We have several others lined up. Actually, Abhishek and Mesh are going to be doing a couple. If you have any requests, let us know, and we'll see if we can create something that speaks to challenges that you and your colleagues may have. We want to keep them not super specific, obviously, but it's always good to hear feedback from those of you in the community on what you're working on and where you might be experiencing some pain points. Here's our quick little next few weeks. Also, teardown channel. Pallav Agarwal has a bunch of teardowns that he's putting into this specific channel that you're able to ask questions about. So it's just over there in the dev forum. So if you go down past like IoT and networking over there, you can find it and see what he's been ripping apart. Also, we have a recruiter who's helping out. So if you know anybody who's looking for work or know any positions that are open, throw them in the jobs channel, please. Then Marcus Webster, he'll go in and see if he can do some matchmaking. Other than that, any suggestions, anything that we can do to get 1% better by next week? I know something that I've been working on, which is essentially getting enough of this stuff coordinated so that we can publish a schedule so that, for example, you can look down the calendar and see topics that may be of interest for you. But anybody have any other suggestions for us to keep getting better? As always, we're at 100% already.
I would like to just say that I don't have a tip how to get 100% better by the next week, but I would like to ask you how to promote the server on the LinkedIn. I noticed that we are promoting the server, especially during the sharing videos from our demos. But how to use it normally? How to use it like regularly, not on a specific occasion?
Yeah, so we can take this offline, but what I'd suggest is if there are questions or comments or discussions, right, that are happening that you think are interesting, you pull that, maybe part of your own, promotions for yourself better is if there's a thread that you think is particularly valuable to the community, just pull it out, right, and start that conversation out, out in LinkedIn or wherever, and just point people back, for the discussion here. Then there's some other templatized sort of posts that we've got that I can share with you. But then other than that, we haven't gone into our full blown, promotions yet, where we're promoting to like tens of thousands of people on some of the lists that are at our disposal. So we'll sort of evolve. But yeah, if you ever want to do that and you need help or need materials, just let me know.
Okay, thank you.
You're welcome. Anyway, does anybody have any proposals for the community or need anything from the community before next week? Okay. Here's some resources. I actually am going to drop. Oh, it's already in here. I already put it in here. This is the blog that I was talking about that Navdeep wrote, and it's also in the chat over there. And I'll make a note to point to it in the general chat. And other than that, that's it for this week, guys. I really appreciate you joining, and I hope you have a great week. We'll see you next week, and we'll see you in the server.